Welcome to the GeoTalk podcast, where we discuss civil, environmental, and geotechnical engineering, geosynthetics, and other issues related to infrastructure. I'm Chris Kelsey, editor of geosynthetica.net. For this episode, I had a chance to sit down with Jay Sprague of the South Carolina-based Denver Downs Research Facility. The site supports large-scale standardized testing of erosion and sediment control materials. We discussed an interesting project Jay has been involved in on pull-out anchor testing of these materials and systems. The work was motivated by a private client's research interest, but actually ended up revealing previously unachieved data. With a little more input from the field, this work may lay the foundation for a new standard. I'm here with Jay Sprague, who's the laboratory director for the Denver Downs Research Facility in Anderson, South Carolina. It's a facility operated by TRI Environmental. Jay has been involved in the evaluation of anchor systems through full-scale pull-out testing. Jay, describe this research and how long it's been going on. What are you testing?
So, in the spring of 2016, we were approached by one of our clients to answer the question, how well do anchors that are designed to be used for rolled erosion control products actually work? Their idea was to create a proprietary anchor design that could replace your standard commodity products, 6-inch staples, washer pins, rebar J-hooks, etc., by applying a little science to the design and construction of the anchor itself. So we came up with a design, I believe it was March, of a test apparatus that was very simply a soil-filled box with a pulley system attached to it.
Okay.
That pulley system could be fastened to an installed anchor on one end and a loading vessel on the other end. And in between those 2 points, a load cell to record the weight.
Okay.
As we load the vessel on one end, it applies a dynamic gradual load to the anchor, to the installed anchor. At the point where that anchor pulls out of the soil, the load cell records the maximum weight at which that it felt. Mm-hmm. And that is, depending on whether it was a single or double pulley, that means either a pulley directly to the anchor or a pulley connected to a pulley that's connected to the anchor. We would either take the measurement directly from the load cell or multiply it by 2.
Okay.
Just simple physics. And that number is the ultimate pull-out strength of a given anchor. And we evaluated proprietary anchor types, staples at different lengths, washer pins at different lengths, rebar J-hooks at different embedment depths, with 3 different soil types, and confirmed the compaction rates of all the different soil types, and did 10 replicates of each of the different products in each of the soil types, and developed a really elegant demonstration of anchor performance that had really not been put out to industry before.
Yeah.
So it's kind of exciting that even though it's a rather elementary and simple test to run, it provided data that just simply did not exist prior to the research.
Sure. What are the applications that are going to benefit most from this type of information?
I believe the applications that benefit most, first off, are encouraging industry to innovate in an area that has been relegated to nothing more than commodity status for the entirety of at least as long as I've been in the industry. Secondly, I think it will allow engineers to more accurately specify a erosion control system on a certain project. So part of the rationale was, as a whole, engineers and designers are being encouraged by industry to utilize high-performance turf reinforcement mats in high-flow, high-erosion risk scenarios, namely channels or steep slopes. Well, oftentimes those TRMs that are designed to withstand shear forces of 10 pounds per square foot or 8 or 12 pounds per square foot are anchored with staples that are 6 inches long and have absolutely no performance criteria whatsoever.
Yeah.
And so if the main purpose of that TRM is to protect soil and grass seed until we can establish vegetation in that channel, but we aren't using anchors that provide the same anchoring capability that the TRM provides shear force resistance, are we really using a system-wide approach to erosion control in high erosion risk scenarios, or are we throwing down a material without consideration of how are we making sure it maintains intimate contact with the soil and provides the ultimate basic goal of erosion control, which is to establish vegetation?
Sure. Do you see this testing protocol becoming a standard down the line?
I absolutely do. My goal is to pursue this particular test method, at least the bones of it, further into a standardized test method. I think the program that we developed was very promising in that the results it provided kind of laid a groundwork for the apparatus, experimental design, reporting, and data analysis necessary to understand the performance characteristics of different anchors. I don't believe that the standard is, or that the test method is perfect. I think that industry input will be hugely helpful in advancing it and making sure that that we have a standard that truly answers the questions that we as an industry have about anchor performance. And this is where the work starts. This presentation was reason to get the word out and to share some experience that we've had at Denver Downs Research Facility with this particular test method, and hopefully get some feedback on where to go next. What are the negatives that we see in the test method? What are the the gaps that we see in the test method, and how do we correct those gaps so that we can come up with a crisp, clean, standardized test method to go forward with in the future?
Yeah. Is there any period already set up to when you will be investigating this more with your industry colleagues, like an ASTM meeting or an IECA Southeast chapter meeting?
I hope to have a rough draft of a standard put together potentially by January 2018 at the New Orleans meeting of ASTM, and kind of take that further through the process. But I believe that it's necessary to have a little further research done before I pursue too quickly a standardized test method. In discussions with some of my clients specifically, I think there's a great need out there to have a test apparatus to validate computer models related to larger anchor sizes, wire and plate type anchors, percussion anchors, and I think that's the next step. I think if this test method can not only incorporate commodity, low margin products like anchors and washer pins and staples and rebar J-hooks, but also give manufacturers and innovators a way to validate their theoretical models on their larger, higher margin products.
Yep.
I think that's really where the value of the test method comes to the forefront. And so I would like to pursue partnerships with private parties to have that testing done and try and figure out if it's even appropriate to test these products at the scale, at the larger percussion type anchors at the scale that we're doing now, or if there's adjustments that need to be made in the test method to accommodate for larger products. And I would like to just have that information before I move forward too quickly on a standard.
Yeah. That sounds wonderful. Jay, thank you for sharing your insight.
Thank you, Chris.
For more information on TRI Environmental's research at DDRF and erosion and sediment control testing services, and to contact J. Sprague, visit www.erosiontest.com. We have also added links and contact information on Geosynthetica. Visit www.geosynthetica.net and click on the Media tab for GeoTalk podcast links, contacts, and resources affiliated with each episode. Thanks for listening.